Hello and welcome back to the WSMX programming training. Here in this lab recording video, we are talking about lab number 2, the creation of a distortion test. So before we go to task number 1, let's have a short look at the learning objective. So here you will go through the procedure for generating a simple distortion test by manually creating the specification file and the operating sequence file, as well as implementing a corresponding subflow and test method. You will use an AWG instrument of the WSMX card to generate a sine wave and use a digitizer instrument to capture it. And by that we hope that you will get a good overview of how to work with the WSMX instruments. Um, for getting started, your project files are imported and the test program is activated. That's basically the status where we left from lab number 1. And I think that one is important here. If you're running the labs offline, you should follow the suggested file name and capitalization explicitly to ensure offline result emulation is functional. So that means if you're running an offline session, for example, if you use the virtual playground on the Advanced Dojo e-learning platform, then you are running an offline session and then you really have to stick to the file names and the capitalization as given here in this lab manual. Otherwise, the offline result emulation will not work. And then make yourself familiar with the keyboard shortcuts provided in the quick reference cards section at the end of this manual. So you have that here, the quick reference cards, and then you see here a couple of shortcuts. And I think it's not worthwhile to go through them here um, in detail, but just that you know that those exist. Okay, and with that, let's jump into task 1. Create AWG and digitizer actions in the specification file. Um, so for that, I will actually pull that over here. And so in the source folder, create a specification file, distortion.spec in the source folder here. So for that, we go basically here and um, right click here, and then we have new, and we go with the specification file first. And in the lab manual, it says that we should name it distortion AC and finish. And then we have here our new spec file and here that one. So, and then actually the code which we have to insert is given here in the lab manual, but I think we should do this now by ourselves, and by that really make use of the content assist. Um, and for that you can just control space, and then you get here already a suggestion of things you can do. And for example, we can here just press enter, and then we have the action source wave sine is given in the lab manual. We have here again the action um, measure wave sine, and then we can actually set our waveform. So if we start typing waveform, then um, control space will automatically give us that one. Then we say we want to have a sine, and then we call it sine wave underscore 5 p 95 megahertz, and then brackets, and then for example frequency you can use the content assist, and then we put in the 5.95 1 to 5 megahertz. Also here we can use content assist. Um, if you ask yourself why exactly this frequency, that probably is to have this coherent sampling condition fulfilled. I think that is also part of the training slides, or otherwise it's part of mixed signal fundamental testing, and then I would ask you to do some research on your own um, to get more information on that. So now samples, we say that's 1024, and sample rate, we have it here, is 100 megahertz. And I forgot, of course, here that one. And now we have the setup of the waveform. Create an AWG source waveform action to source the analog waveform via pin WSMM HS01X1. So now we are here at point number 6, and we basically gonna add the setup of the AWG instrument here with the action source waveform. So we go back to our specification file, and now we have setup, content assist, AWG, and then we use the WSMXH. Here, if you also type in something and you hit control backspace, you get the list of signals which we set up in our .board description file. And as mentioned in the lab manual, we're gonna use that one here. And we continue, and it says config options dot options internal cross connect. We also have it here. So content assist is really useful. We have here action source waveform. It's automatically giving us that because we have the AWG, and source wave sign. That's now the waveform. Um, no, that's actually the name which we specified up here. Okay, and then we have to add a waveform, and then it's already, if we just hit control backspace, it's already giving us the sine waveform, which we actually set up here in the upper part of the specification file. So we just click on that one. We have to specify the bandwidth. That's 8 megahertz. Whoops. Um, Amplitude is 0.35 volts. Offset is 0 volts. Whoops. And the repeat count is how often we want to repeat this waveform is 10 times. Okay, so that is the setup of our AWG. Basically what I did is just keyed in this part here, but using the content assist, and by that you can be very fast. Next one is step number 7, create a digitizer measure waveform action taking 2048 samples at 200 megasamples per second. So we're gonna key in this part here. For that, here we have our setup of the AWGs. So we go here and set up the digitizer. Here we go. And for that, we're gonna use the corresponding neighboring signal. Config options, also internal cross connect. Why not? Action measure waveform. It's the only action a digitizer can do. And then we're gonna have measure wave sign here, the one which we specified here up there. Samples is mandatory 2048 as given in the lab manual. Low pass filter bandwidth is 8 megahertz. The sample rate 200 megahertz. So all I'm doing here is now just type in the first one or two letters of um, the property I want to use. So for expected amplitude, just go with EX. Oops, click here, EX, and then control space, and then this one pops up here, and then you just hit enter, and you're here with the content assist. Okay, so that was basically already task number one. So I'm gonna save this spec file here now, and we gonna continue in a separate video with task number two. So hear you later.